Hello everyone, a video on real numbers in which we would see and understand the proof for various irrational numbers. So let's begin. So now let us prove this result. We are asked to prove that root 2 is an irrational number. We'll do it by contradiction. Let's assume root 2 is not irrational, but it is a rational number. Now, if this number is not irrational and is rational, that implies root 2 can be written as p by q form, where p and q are integers and q is not equal to 0. Okay. Now if p and q are integers, let's now put them in the lowest term, or root 2 can be written as a by b, where a and b are co-primes. So what we did, we had this number root 2 in p by q formation, where p and q were integers, and we have expressed it in a by b form by dividing p by q by their HCF. So root 2 is a by b, where a and b are co-primes. Or if I take this to the other end, this is root 2 into b equals to a. If I square both sides, it's 2b square equals to a square. Now this is actually your theorem 1.3, which says if 2 divides a square, then 2 would divide a as well. Look at this. Can I write it in the form b square is a square by 2? This means if 2 divides a square, 2 will divide a as well. This is clearly according to your theorem 1.3. That means, see, if 2 would divide a as well, that implies a can be written as 2 into product of any integer, 2 into c. Let a is 2 into c. Now put this value from equation 1 in this expression, in this equation. Let me make it equation 2. Let this be equation 1. Put a equals to 2c from 2 in 1. So a equals to 2c, put this value from 2 in 1. When we substitute the value, we know b square was a square by 2. Okay, put the value of a as 2c. So this becomes b square is 2c whole square by 2. Further, when you simplify, b square would be 4c square by 2, which on simplification would give you b square equals to 2c square. Now what does it mean? If b square is 2c square, this implies b square by 2 equals to c square. We can say if 2 divides b square 2 divides b as well. Now initially we said that a is divisible by 2. Also, now we have proved b is divisible by 2. From here we conclude that a and b are not co-primes, because we know co-primes are the numbers which do not have any common factor other than 1. But we observe that a and b has got one common factor, which is 2. So if a and b both are divisible by 2, they are no longer co-primes, and if they are not co-primes, that implies our assumption is wrong. It's a contradiction. Our assumption is wrong. Hence, root 2 is not rational. It is not rational number. It must be irrational. Hence, the result is proved. So we prove this result by a contradiction, by assuming it to be rational, and we landed up in a situation which says that if it was rational, then the representation for root 2, which was written in a by b form, those a and b were taken as co-primes, but यहाँ पे क्या prove हो रहा है? They are not co-primes. So our assumption is proved wrong, and this wrong assumption is due to this contradiction has arisen due to wrong assumption, and hence root 2 is not rational. It must be irrational. So root 2 is irrational number.